Hi, this is Mrs. Cahill with your Notes 3.2, Relations and Functions. You're going to copy the vocabulary on this page and your heading into your notes. And then we'll work from a foldable and your note-taking guide. So the first is the definition of a relation. That's a set of any ordered pairs x and y. So anything we put on a graph will always be a relation. To be a function, it is still a relation, but in this case, each input or x value has exactly one output or y value. So today we're going to see how that works. All right, now we're on the foldable, the top left corner. Use the vertical line test. If a vertical line passes through the graph more than once, then it's not a function. Here's what we mean. You can use a pencil, and I've created a vertical line, and I'm going to go to this first graph. When I put this vertical line anywhere on this graph, it only touches in one spot. That's why this one is a function. Let's go over to the other one. When I take the vertical line here, you can see it's touching 2 times. That's why this one is not a function. Okay, now the next part just says that a graph is always a relation. If I can put it on an x and y coordinate plane, then it's a relation. Now let's talk about the domain and range for each of these. So the domain are all of our x values. This parabola goes on forever, so it's going to keep getting wider in both directions. That means that x is all real numbers. It's infinity. But the y values, we start this high and then we go lower. So what are our y values? They start as high as 1 and then they get smaller. And again, the domain was all real numbers. Now let's look at this one. It's not a function. It's a parabola that's sideways. I see that my x values start here at -1, and then they keep getting bigger. So what does it say about that? That means our domain starts at -1 and gets bigger. Our y values, this parabola will keep getting wider and wider, go higher and lower. So our range is all real numbers. So now move to the top right corner of your foldable. If the x values of the ordered pairs are repeated, then it's not a function. If there is an x value and a y value in each ordered pair, it's a relation. All of these are relations. And then we're going to give the domain and range for each. So now let's go see if the x values are repeated. I look at this first one, they say it's a function. Notice my x values. I have 3, 2, and -3. There are no repeats. That's what makes this a function. When I go to list my domain, I have 3, 2, and -3, and they are listed. Now, I prefer that my students list their domain in numerical order, but I'll accept this on the worksheet. The range will be our y values, and we've got 4, -6, and -6. Notice down here, I didn't write the -6 twice because when you list your domain and your range, you don't list the repeats. You only list the different numbers. All right, the next list of ordered pairs is a relation, but it's not a function. Notice my x values repeat. It's x that is repeating. When it repeats, we are not a function. Now we can list our domain. I see 3, 4, and 3. You know I'm not going to list that 3 2 times, so it's 3 and 4. For the range, I see 4, 1, and -2, and it is preferred that you list those in order from least to greatest. In fact, while we're at it, let's show why this isn't a function. I can plot these points on a coordinate plane. See the point 3, 4, and 3, -2? They're on top of each other. If I were to apply the vertical line test, I can see that my vertical line touches here and here. And remember, if the vertical line touches more than once, it's not a function. All right, the next quadrant, the bottom left, if the x values of the table are repeated, it's not a function. So let's go down here and look. Do we have any repeats? No, we don't. So guess what? This one is a function. All right, let's look to the right. Do we have repeats? Yes, we do. This is not a function because my 8s are repeating. Notice back at the first one. Do you see how -2 in my y's repeat? That's actually okay. It's okay to have your y's repeat. You just cannot have your x's repeat. So now let's list the domain. The first one was done for us. They didn't put, well, actually, they did put their numbers in numerical order for the domain. The range, not in numerical order, that's not preferred, but do notice the -2 happens twice in my table, but I listed only once in my list of range. For the domain, see those 8s? I will not list those twice, and I have put mine in numerical order. So we've got -4, 0, and 8. For the y values, no repeats there. Every single number will be listed, and mine are in numerical order. All right, real quick before we move on to the next box, what is a mapping diagram? Well, a mapping is almost just like your table. So here is a table, and I'm going to turn that into a mapping. So I will take my x values and put them vertical instead of horizontal, and my y values are also vertical. And notice one thing. See this repeat in my y values? When I make a mapping, I don't repeat that 2. So now when we go to make our mapping, notice -3 is supposed to point, -4 rather, is supposed to point to 3. That's what I do. 0 points to -2, 2 points to -2, and 5 points to 5. That is a function. It is okay to have your y's repeat. You just cannot have your x's repeat. So now let's check on the next one. If I make that same type of mapping, I see that 8 needs to point to 3. -4 is pointing to 1. 8 is also pointing to 2. And 0 points to -6. This is not a function. A little easier to see from the table because I see my 8s are repeating, but here's the part you're looking for. I can't have my 8 point to a 3 at the same time it's pointing to a 2. That is what makes it not a function. Notice this right here, both pointing to a 2. That just meant my 2's were repeating. This is okay. It's still a function. And that's what you have on this table. Remember, when we create the mapping diagram, we're only going to enter each x or y value once. All right, now we're on to our note-taking guide. We're going to express each relation as a table, as a graph, and as a mapping diagram. So the relation represents ages of students and the number of words they can write per minute. And we can take our x values and list them. 5, 6, 6, and 7. And our y values 10, 20, 23, and 35. That's pretty easy. Now we can graph them. 5 with 10. I'm going to pause. And so I have plotted my points. Do notice, remember how my 6's are repeating and this isn't a function? Also notice we do fail the vertical line test. My vertical line touches twice. And now let's make that a mapping diagram. So I will write the 5, 6, and 7. I did not repeat my 2 6's. And then my 10, 20, 23, and 35. And now we can point. 6 goes to 20 and to 23. That is okay. No, that's not okay. That's what makes it not a function. So we can even circle on our paper that this is not a function. By the way, while we're at it, do you remember from before? Is this graph discrete or continuous? It's discrete because I have individual points. There's no points in between those points. All right, number 2, use the graph to answer the question below. They want to know the domain and the range. So where do my x values start? My x values start at 0 and they go on to infinity as that graph goes higher and higher. So how do I state that? Well, x starts at 0 and includes 0, but gets bigger and bigger. The y values start down here at negative 2, let's start with the y, and I'm comparing it to negative 2, but it only gets higher and higher, so y is greater than negative 2. For graph B, let's compare our domain and range. My domain starts at negative 5 and goes to 1. So I'm comparing it to negative 5 and 1. X is in between those values. It is equal to the negative 5 because my dot is filled in, but it's not equal to the 1 because my circle is open here. Now let's look at the y values. Y starts down here at, what value is that? Negative 6? And it includes the negative 6, and it goes as high as 2, but it doesn't include the 2. So is this a function? Well, yes, it is. It passes the vertical line test. Is it continuous or discrete? It's continuous because we have dots in between the dots. It doesn't need to go on forever to be continuous. I need dots in between the dots. On the last one, by the way, it's also continuous because we have dots in between the dots. All right, let's look at C and D. Our domain, our x values start at 4 and go to 5. So we're in between 4 and 5 continually, and we are not equal to either one. For our y values, we start down at negative 4 and we go up to 0, and we don't equal either of those numbers. Now let's do the domain and range for this one. Well, my x values will keep getting more and more negative and keep getting more and more positive. Actually, I just showed you the y values. It goes on forever in both directions, so we can just say that our domain and our range are both all real numbers because that's a line. All right, number 3. State the domain and range of each relation. So you're just going to list your domain numbers here and put them there. I'm going to pause and do it. You do it too, and then compare. And hopefully that's what you got for your domain and your range. We do the same thing for the next one. And I've listed my values there. I have made the effort to put my numbers in numerical order from least to greatest. All right, the last one is kind of neat. We're going to do that from the graph. So I want to look at my domain. I see I have first a value at negative 5. Then I have one at, oh, I lied, that's at negative 6. The next one is at negative 2. Then I come over here to 2 and 4 and 6 and 8. Now let's look to see how high and low, or what the range is. We start down at negative 6. Then we go up to negative 4. Do you see that happens twice, but I only write it once? Then we go as high as 0. And finally as high as 4. On number 6, which of these is a function? So remember, to be a function, I cannot have my x values repeat. See right here? That makes that a no. And right here, I have my 1's repeating, so that's a no. We have our 16's repeating, that's a no. Only this one is our function. My y's do not, my x's do not repeat. Number 7, is each a function? Justify with the options below. By the way, these options here would not be the options you would actually see when you do each one of these questions, because the ones we're about to do will have multiple answers, and when you make your choices, you'll only have one correct choice to choose from. So this is just for demonstration purposes. So we look at the first one, and we see that negative 4 is repeating to 2 values. That means when I put in negative 4, I don't know what's coming out, a 4 or a 7. So this is not a function. Which one of these says that? Well, actually, everything A, C, and D says that because we have got more than one y value associated with an x value. In this case, the choices are A, C, and D. But again, when you're on Get More Math, you'll only have one correct choice, but you will need to look at the wording. On the next one, my y's are repeating, but each x value is only associated with one y value. That is a function. And the choice for that one is B. There is only one y value for each x value. Remember, it's okay for the y values to repeat. All right, on the last one, this one's a little more obvious. Each x value has only one y value. This is a yes, and this is a more obvious yes. All right, on these graphs, we're going to determine if they're functions. By the way, they are all relations. And so all of these are going to be functions except one. Let's use our vertical line test. I can make my vertical line touch in only one place. And it works the same on the next graph. Touches only once. Even on this graph, it touches only once, but clearly on the circle, it's touching twice. So this is the one that is not a function. Okay. Number 9, all are functions except which one? You pause the video and look for your answer. So we're looking for the one where my x's repeat, and that appears on this one. When I put in 20, am I getting out 6 or negative 9? I don't know. That makes that not a function. All right, here's our last one. Which one is not a function? So I am looking for my x values to repeat. And I see in my table that my 5s repeat. I get a negative 14 sometimes. I get a 16 sometimes. And that's what makes it not a function. Now you are set to move on to your Get More Math problems. Remember to keep up with your points. And you should be allowed some extra credit if you do more problems than required for the week.